One aspect of using the Octatrack that's often overlooked when coming from the land of 32-bit floating point is how easy it is to end up with clipping in your signal chain. First, I'm changing the memory configuration to 24-bit and enabling dynamic recorders. These are the two main changes I tend to make in a default project. Some of the sonic artifacts and effects will sound a bit different at 16-bit, so it's somewhat a matter of taste. But having dynamic recorders on makes for a lot less hassle when messing around with record buffers. I'm also going to be leaving the master track off for this demonstration. I'm going to set this first track up as a flex machine playing a single cycle waveform, specifically a perfect sine wave. I'll leave all of these settings default, and I'm going to set both of the effects to none. Don't worry, we'll get back to those effects in just a minute. Now to load a single cycle waveform to the flex machine slot, I'm going to be using the Adventure Kid waveform's perfect waves. Using a waveform with the simplest harmonic content possible will make it much easier to hear clipping. Since I left my flex machine playback settings to default, I need to set the loop behavior in the sample itself. By default, loop and time stretch are set to auto. Time to get a trig down. Nice basic sine wave. In the sample attributes, we actually have up to 24 decibels of gain. So let's try adding some gain. So where exactly is that clipping happening? One way to get a bit more insight into what's happening here is to use the Octatrack to monitor itself. So I'm going to set this channel up as a master track oscilloscope that records from the main, and set that source 3 and get a trig down. That's going to be very useful, but we also need to be monitoring another source, specifically the pre-fader level of track 1. I'm doing pretty much the same settings here, except I'm going to set the source 3 to be T1. Now to get a record trig down. Now to save some button presses, I'm going to set track 7 and track 8 to be flex machines pointed at their recording buffers. Let's take a look at those recordings now. You can see that the signal is being attenuated as it goes into the main output, and that's from the track level fader. So turning up the track level to maximum will equalize these two recordings. Now let's go back to our sample gain and see what happens. All that gain is definitely showing some rough edges on the signal, but we're not technically clipping yet. Let's add some more gain and take another look. And now we're clipping everywhere. After the sample gain, the second gain stage in a track is with the vowel parameter. Generally, I like to reserve this particular parameter for modulation rather than using it as a gain stage. I'm curious how much gain we can get out of this. Since I'm using a flex machine, there's actually another source of gain available at the sample level. You can increase the volume of a selection of the sample in 3 decibel increments. I'm going to select the whole sample. It's very interesting how it decided to clip that. Let's do it a few more times. Okay, let's revert back to the saved file. Revert to saved file is very useful when working with record buffers or when using the editing functions in the audio editor. Let's take a closer look at that waveform after adding some gain. Quite a bit different effect than simply clipping the sample through the track itself. When I put the filter on and off this track, you can hear a bit of a click and a noise. These artifacts become much more dramatic when we increase the sample gain. With this simplistic clipping test, we can easily identify which effects are not transparent at their default settings. The primary offenders are the filter, DJ EQ, and lo-fi effect. Switching to the compressor also causes a click, but that's primarily because the compressor by default is 100% wet. The lo-fi effect is the most egregious, immediately leading to lost signal level. It's rather clear from looking at the waveforms that the lo-fi effect is internally clipping with a rather low threshold. We can clearly see a difference in the pre-fader level recording. Let's get the filter back on there. The filter is also doing some very similar internal clipping when you engage its distortion parameter. You can clearly hear and see that we've lost quite a bit of overall signal level. Let's adjust the distortion parameter on the lo-fi effect and see what happens. It's essentially controlling the ceiling or threshold for saturation and clipping. Personally, I would have preferred that the output level stay constant as the distortion increases. Now let's go take a look at the DJ EQ. Even with no gain applied, you can clearly hear phasing artifacts introduced by this EQ. Overall, it's very crucial to pay attention to any parameters in the effects that can affect the overall signal level, like the resonance control of the filter, for example. The very high signal levels clipping the input of this filter are creating a lot of harmonic content for the filter to chew on. Since the source is so harmonically simple, once we remove some of that clipping, the interaction of the filter cutoff frequency and the Q becomes much more dynamic. Somewhat obvious gain-related parameters include the feedback and mix controls of time-based effects, such as phasers or comb filters. But any frequency-related control should also be carefully considered as a potential source of change in signal level, such as the center frequency of a phaser or the filtering on a reverb. To work with a more dynamic sound source, so I'm going to make some slight alterations to this sine wave track. If you want some more dynamics in your signal, the first place to look, of course, is the amplitude envelope. Since this is just a plain sine wave, I'm also going to put a pitch envelope on it to get some more frequencies happening. And switch that trig behavior. take a look at the waveform on that. Let's see what our excess gain does to this. Definitely clipping the track. And now if I turn down the track level, it's clipping inside the track, but not on the way out of the Octatrack. Okay, time to turn it back down now. Now to turn the track level back up. Now I'm going to add a dark reverb to this track, as the dark reverb is tuned for producing very long reverb tails. This makes it very susceptible to internal clipping and overloading. The default setting has a fairly low time value, but the filters are wide open, and even just turning the mix up a bit, we get very close to clipping. Excess energy easily builds up in the dark reverb feedback delay network. Even a slight increase in mix value can quickly start some resonance building up inside the feedback delay network. And of course, at this point, we're just straight up clipping the track as well. Let's pull back that sample gain. Now to crank up the mix and time and listen for some low frequency distortion and rumble. You can really hear the low end clipping and fuzzing out. Let's take the sample gain to 0. You can still hear that it's overloaded and clipping internally. It's very helpful to use the filters to control the signal levels. With the low-pass filter wide open and the shelving frequency at maximum, as I turn up the time value, you can hear some high frequency build up. I'm going to put a filter into the first effects slot to get a bit more movement in this sound and add an additional frequency. There we go. That's a bit more for the reverb to work with. Now that I have the filter in front of the reverb, let's add some of the sample gain back. Let's take a look at what clipping is going on now. Yeah, that's a lot of clipping. The gain reduction of the distortion on the filter can be useful for reducing the internal clipping on the track. If you want full control of the effects gain stage, then you're going to want to use a compressor in one of the slots. But it can be useful to remember the effects of the lo-fi and filter distortion. Always pay careful attention to the shelving frequency when adjusting the dark reverb. And if I disengage the filter distortion, we're right back to clipping. With high feedback levels on the flanger and comb filter, you can end up with very high signal levels that you'll often need to tame with the compressor if you want to avoid clipping. I'm going to clean this up. Now back to that flanger. Let's see how bad we're clipping. Getting some big resonant peaks and valleys. I'll turn down the feedback a bit and take a look. Now to add a compressor. Having a compressor at the end of the chain allows for greater control over the final gain stage before the track level control. I'm not going to add any gain, just dial in some gain reduction. No more clipping. I have an idea. This won't be very pleasant.